Hey guys, have you ever wondered what our future be like? Given the current situation around the world, there are wars, the threat of wars, food scarcity, global warming, infectious diseases, political divisiveness, and so on. What's going to happen to us? Will we be able to colonize Mars? Or AI will finally be sentient and take over us humans? Well, that's a story for another day, but as humans, we always try to envision things. So, the main question is, can we predict the future? Can science and mathematics be able to answer these questions? Let's find out.
Isaac Newton came up with classical physics or Newtonian's law of motion. His first law states that an object at rest will stay at rest until acted upon by an outside force, and an object in motion will stay in motion until acted by an outside force. Basically, in Newtonian's physics, it's helpful to think that the universe is sort of a massive machine, a clockwork, where every object in the universe in motion or otherwise is in that state as a result of all the different forces acting upon it.
Example, a dice toss. To the human observer, the results of the dice toss seem completely and totally random. But that's only because we don't know all of the input forces acted upon that die at that time. There are too many factors to consider. The upward force of the thumb, the Earth's gravity, the air resistance, wind, and also the gravity pulse of every other object in the universe. There are so many forces affecting the way the die lands that it is far too complex for us to predict the outcome. So, to the human observer, we call this phenomenon randomness. But there was nothing random about it. A die cast in the exact same way with the exact same forces acted upon it will land exactly the same way every time. We call this clockwork universe theory or Newtonian determinism, leaving no room for the operation of chance, one whose future was completely determined by its present.
Pierre-Simon de Laplace, and this intellect were vast enough to submit its data to analysis, then the future, just like the past, would be present before its eyes. Pierre-Simon de Laplace, in his 1812 book, Analytic Theory of Probabilities. He is a French philosopher and an outstanding mathematician who reasons that we have no freedom, that there is no such thing as free will, because we live in a purely material and wholly determined reality. He suggested that it's not logically impossible to predict the future. He believes that if the universe is a closed system that operates in established rules, then there is no such thing as free will. We're not making choices. The things that feels like a choice were not really a choice. But is he right? In our daily lives, we encounter cases where Laplacian determinism seems to be an inappropriate model. We walk safely down steps 1,000 times until one day we turn our ankle and break it. Why does so much our experience indicate that he is wrong? The next subject claims to have many of the answers.
See, the Tyrannosaur doesn't obey any set patterns or park schedules. It's the essence of chaos.
I'm still not clear on chaos.
It simply deals with predictability in complex systems. The shorthand is the butterfly effect. A butterfly can flap its wings in Peking, and in Central Park you get rain instead of sunshine.
Why?
And then I go too fast. I go too fast. I did a flyby. No, give me that big glass of water. We're going to conduct an experiment. It should be still. The car's bouncing up and down, but that's okay. It's just an example. Now, put your hand flat like a hieroglyphic. Now, let's say a drop of water falls on your hand. Which way is the drop going to roll off? Over which finger, or over the thumb, or the other side?
Thumb. That's it.
Okay.
Right.
Okay. Now freeze your hand. Freeze your hand. Don't move. I'm going to do the same thing. Start with the same place again. Which way is it going to roll off?
Let's say back. Same way.
Same back. It changed. Why? Because tiny variations, the orientation of the hairs on your hands,
Hey, Ellen, look at this.
the amount of blood distending your vessels, imperfections in the skin,
Imperfections in the skin.
microscopic, and never repeat and vastly affect the outcome. That's what.
Unpredictability.
Right? Okay. Look at this. See? I'm right again. Nobody could have predicted that Dr. Grant would suddenly jump out of a moving vehicle.
Alan?
There's another example. See, here I am now by myself, talking to myself. That's chaos.
Chaos is a science of surprises, of the nonlinear and unpredictable. It teaches us to expect the unexpected. Chaos theory deals with nonlinear things that are effectively impossible to predict or control.
Imagine you're a computer scientist specializing in simulations of dynamical systems like that of the weather. As a result of extensive scientific research and your own ingenuity, your simulations are able to perfectly predict how these systems change over time, given any set of starting parameters. However, you must still be extremely careful in using these simulations to predict what happens in the real world, as it may result in a wildly inaccurate and completely different prediction. This is due to the fact that these systems are chaotic. A safe prediction is only possible if you can make measurements to infinite precision, infinitely many decimal places, and of course, there's no way to do that. Incomplete set of starting parameters results in an amplification of error. This phenomenon is called sensitivity to initial conditions, or simply called the butterfly effect.
The butterfly effect. In pop culture, the butterfly effect has come to mean that even tiny, seemingly insignificant choices you make can have huge consequences later in your life. The reason people are so fascinated by its fundamental question, which is, how well you can predict the future?
The idea was coined by Ed Lorenz. He was a meteorologist. He tried to make a basic computer simulation of the Earth's atmosphere when a breakthrough came in. He tried to redo a run, but as a shortcut, he entered the numbers from halfway through a previous printout and then set the computer calculating. He went off to get some coffee, and when he came back and saw the results, he was stunned. The new one followed the old one for a short while, but then it diverged, and pretty soon it was describing a totally different state of the atmosphere. He later found out that the first computation results were originally 6 decimals rounded to 3. On his second run, he used just the rounded results, which is 3 decimals. The tiny variation in the initial condition of his second run explains the error amplification.
Lastly, phase space, developed by Henry Pointer. It is an imaginary mathematical space that represents all possible states of a dynamic system, with each possible state corresponding to one unique point in the phase space. It is a 3D place in which you plot the behavior in order to create a phase portrait. Instead of having to define a formula and worrying about identifying every number of the behavior, the general shape can be determined.
Here's an example of a visual representation of a phase space. Three closely spaced initial states evolving together, but little by little they start to diverge. From being arbitrarily close together, they end up on totally different trajectories. This is sensitive dependence on initial condition in action. There's nothing random at all about this system. It's completely deterministic. If you could input exactly the same initial conditions, you would get exactly the same results. So, can we do it? Can we really predict the future? Well, according to Newton and Laplace, this is possible. They believe in a deterministic world, but with the introduction of the chaos theory, you actually cannot. I think that without the perfect knowledge of initial conditions, any prediction really is basically useless. And getting that perfect knowledge too, it's an impossibility. You'd be dealing with massive numbers, decimal places, a lot of them. It's huge. Even a supercomputer won't be able to handle that magnitude. So yeah, we just can't. So there's no telling if we can really reach Mars or if AI will finally drive us into extinction. Science and mathematics did provide us an answer. Partly you can and partly you cannot. But I'd go with the latter, the chaos theory. So yeah, we just can't. And unfortunately, to the hopefuls, we can't really cheat our way to winning that 658.